Looking at graphing logarithms, we still have our parameter change form. And our parameter change form still has our a, x, k, everything like that. A is going to be my vertical dilation. H is still going to be a horizontal translation. K is still a vertical translation. Let's look at this table. I want to keep that color. Complete the table for y equals 2 to the x. So I have -2, -1, 0, 1, 2, 1/4, 1/2, 1, 2, and 4. To find the inverse of y equals 2 to the x. Remember, finding the inverse means we're going to switch our x and our y's, and then we're going to solve for y. When we do this, I get 2y equals x. Quick way to remember how to write the log, I'm going to do this crazy L. So this is telling me I have log base 2, argument is x, equals my exponent y. Look, I just made the equation that I'm trying to find. So that is the inverse for the exponential form. Logs are inverses of exponents, exponents are inverses of logs. So all I have to do here is switch my x and my y from that first table. So I have 1/4, 1/2, 1, 2, 4. And then I have -2, -1, 0, 1, 2. So if I'm looking at the inverse, and typically this term out here, that term out there was my, God, I'm having the biggest brain fart today. That term out there was my asymptote. We now are going to have it be a horizontal asymptote is going to be, vertical asymptote is going to be associated with the x value. So let's look at this first problem. I'm still looking at log base 2. So this is essentially my parent function equation. And I'm going to graph this the exact same way that I've graphed every type of parameter change with any type of quote-unquote parent function. So I have x minus 4, and then y minus 3. It's going to be easier to do our y values, so why don't we do that first? I'm going to take -2, -1, 0, 1, 2, subtract that by 3, and I get -5, -4, -3, -2, -1. Then taking my x column, 1/4, 1/2, 1, 2, 4, and subtracting 4, -3 and 3/4, -3 1/2. Oh, excuse me, my face itches. -3, -2, and 0. I know you couldn't see that, but I still told you. Well, look, doesn't it look like it's slowly approaching -4 from that situation? So I'm going to draw in that as my asymptote. Graphing this. -3 and 3/4, which is super close to -4, all the way down to 5. I have the point right there. Continue on, -3 1/2, 4. Right there. -3, -3. Then it's going to get a little bit faster. Then I have -2, -2. And then I have 0, -1. If I continued on, I could find more points. But looking at this, I can sketch this in. And there's my graph. The domain before, the domain was all real numbers. Now the domain is not all real numbers. We have x is greater than -4. Another way we could have written this, -4 to infinity. The range, before our range was looking at our asymptote and looking at it above or below, depending on whatever situation we have, if we had a reflection or not. Now our range is every single number. This is all real numbers. Another way I could have written it, -infinity to +infinity. The equation of my asymptote, well, that was just looking at my h value, so I have x equals -4. Okay, this next one, I'm going to do in green. I'm not changing my x at all, so my x stays the same. So I have 1/4, 1/2, 1, 2, and 4. If you look at this, this is slowly approaching 0. So I'm going to draw in my vertical asymptote, and I'm going to actually write my equation down here, x equals 0. My y value, you can see that I have a negative on the outside, so I'm actually going to be looking at reflecting this. So everything that I do, I need to switch those signs. Negative 2 becomes positive 2, ditto all the rest. And then I'm just going to graph this. Let's change it to black again. 1/4, 2. Somewhere like there. 1/2, 1. Somewhere like there. 1, 0. I have that. 2, negative 1. And then 4, negative 2. Keep on going. I'm just going to sketch this in. And then I know this is my asymptote, so it's going to approach it, just like that. For this one, I know x has to be greater than 0. Another way we could write it. Oops. Okay, apparently that's not wanting to work for me. Erase, erase. 0, comma, infinity. We're going from 0 all the way up to infinity. My range is still going to be all real numbers, so it's going to be negative infinity to positive infinity. Last one, pause the video, try to do this one 100% on your own. Looking at this, I have x plus 1, so I know it's going to be translated to the right, positive 1. Y plus 2, and there is no dilation factor. So we have 1 1/4, 1 1/2, 2, 3, and 5. Adding 2, I get 0, 1, 2, 3, 4. So where's my vertical asymptote going to be? I hope you said at x is equal to 1. So I'm going to draw that in. 1 1/4, a little bit over. I'm going to start right about here. And then I have 1 1/2, 1. It goes up just a little bit. 2, 2. 3, 3. 5, 4. Right here. Approaches my vertical asymptote, and then we're just going to continue this on. So there's my sketch. Looking at this, x is greater than 1. That could be 1 to infinity. Again, it's all real numbers. So that's negative infinity to positive infinity. And we've already talked about our asymptote. Using the parent function, y equals log base b of x. Write an equation. If the graph is shifted 9 units to the right, 9 units to the right, 12 units up. So I know I'm going to have y, oh, did not change my pen. Y equals log base b. We'll do parentheses. 9 units to the right. Well, that seems like I would be adding 9, but I'm really subtracting it, so it's going to be x minus 9. And then 12 units up is going to be plus 12. State the domain and range of the new graph. So looking at this, my domain, this is putting a limitation on it, 9, so I know I'm starting at 9, and I'm going all the way to infinity. My range is still going to be all real numbers. State the equation of the asymptote of the new graph. Equation of the asymptote. Well, I know it's where I start with my domain, so that's x equals 9.